Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on August 18, 2025, which was about 5 days ago. The big hook is a routing framework that beats the strongest single model by 7% in average accuracy, matches that model at 27% lower cost, and can still deliver about 90% of its performance at 63% lower cost. The paper is titled Beyond GPT-5, Making LLMs Cheaper and Better via Performance Efficiency Optimized Routing. And as we will see later, the results are really impressive. In short, a smart test-time router clusters queries, scores models by accuracy and cost, and then consistently finds the best trade-off across 6 tough benchmarks. Building on that, the tweets highlight dynamic routing that ensembles different models, claiming plus 7% accuracy over GPT-5 medium and up to 63% cost reduction. Several accounts share links and figures, framing it as a clear Pareto improvement and a practical guide to test-time routing. Engagement looks moderate overall, with one post showing about 25 likes, while others register only a handful. Also, the authors shared an implementation on GitHub. You'll find a test-time routing framework called Avengers-Pro, with Python code for simple and balance-aware routers, configs, and embedding cache, and experiment exporters. There's a quick start, JSONL data format, clustering parameters, advanced flags and requirements, plus ablation assets, and an MIT license. Alright, we are looking at a 2-panel figure that maps accuracy versus cost and summarizes key trade-offs. The left panel shows a scatter of single models alongside red stars for routed settings, which trace a smooth Pareto frontier that stays higher at any given cost. The right panel presents bar charts at 2 alpha choices, where alpha equals 1.0 boosts accuracy by about 7% at similar cost, and alpha equals 0.53 matches accuracy while cutting cost by roughly 27%. Together, these visuals illustrate why routing consistently beats any single model. Now we are looking at a cost table that lists input and output token prices for each candidate model, which drives the routing trade-offs. You can see cheaper options like Gemini 2.5 Flash and the QN3 variants, while premium models like Claude Opus and Gemini 2.5 Pro carry much higher output rates, so the router avoids them unless accuracy demands it. This table explains why lower alpha shifts traffic to QN3 and higher alpha leans toward GPT-5 Medium, Claude, and Gemini Pro. Now we are looking at a benchmark summary table that lists each dataset, the evaluation metric, and the sample count, which together define how routing performance is measured. You can see 6 datasets spanning ArcAGI, GPQA Diamond, HLE, Live Code Bench version 6, Tau2 Bench, and Simple QA, all scored with pass at 1. The size column totals 2,603 items, so the evaluation has enough breadth to stress different query types. This breadth matters, because routing depends on consistent per-cluster scores across varied tasks. We are looking at a 2-panel figure that tracks what happens as the performance weight alpha increases. The left plot shows accuracy climbing from the low 40s toward about 66%, with a shaded 95% interval and a dashed line marking the GPT-5 medium baseline. The right plot shows total cost rising from near zero toward about $48, which illustrates the trade-off because higher accuracy comes with higher spend. Together, these curves reveal elbow regions around 0.4 and 0.6 where gains are efficient. We are looking at a comprehensive results table that compares single models to routed configurations across 6 datasets, plus average accuracy and cost. You can see bold entries marking the best per column, which highlight that several routed settings top most datasets and the average. The rows with alpha values show the trade-off. Alpha equals 0.53 matches the strong baseline's accuracy at notably lower cost, while alpha equals 1 delivers the highest average accuracy. Together, these rows quantify the Pareto gains we discussed. We are looking at a 6-panel figure that shows how routing shifts across models as the performance weight alpha changes. The overall layout presents pie charts, so we can compare model shares at each alpha while keeping totals fixed at 100%. You can see low alpha panels dominated by QN3 variants, then mid alpha around 0.53 blends in GPT-5 Medium, and high alpha near 1 tilts heavily to GPT-5 Medium. The legend beneath clarifies each color mapping to a specific model family. Building on those routing shares and trade-offs, the core message is simple. Intelligent test-time routing beats any single model on the accuracy and cost frontier. 2 takeaways stand out. The performance weight alpha lets you dial accuracy versus spend, and cluster-based scoring makes those dials reliable across tasks. Thanks for listening. I am Alex, signing off.